Welcome, geometry students. Today we're going to continue to learn about the target, which asks us to classify and find measures of angles formed by parallel lines and a transversal. So we've already done a lot with corresponding angles, consecutive interior angles, alternate interior angles, and alternate exterior angles. So we should have a very good foundation of where those are located and what relationship is true about those angles when your lines are parallel. So today we're actually going to be looking at the converse of the previous video. So all of the different if-then statements we learned, we're looking at the converse. And just remind yourself, converse statements are the reverse of the original if-then statement. So here's the first converse that we're going to be considering. If corresponding angles are congruent, then lines P and Q are parallel. So now if you notice, what we learned in our previous video was when the lines are parallel, corresponding angles are congruent. Well, the converse is also true. So we can use the given angle relationship now to prove parallel lines. So for example, if this is line P and this is line Q, we don't yet know that those are congruent. But what it tells us is that the corresponding angles are. So, and I'm sorry, I just said we don't know if P and Q are congruent. We don't know if P and Q are parallel. So since we don't know that yet, what we're going to do is use these angle relationships. Well, angle 1 and angle 2 are given to be congruent angles. So since those are congruent corresponding angles, that is enough to prove the lines are parallel. And our reason is just since angle 1 is congruent to angle 2, and those are corresponding angles, then we know P is parallel to Q. Now that's not really a reason. That would be a specific example of what's going on here in this picture. If we were asked to explain this, we would use the original wording that was given at the top of that box. All right, well, what about alternate interior angles? If alternate interior angles are congruent, then lines P and Q are parallel. So now we have two lines. Again, we don't know if they're parallel yet, but what we're going to do is use the alternate interior angle relationship to show that they are. So for example, if angle 3 and angle 4 are congruent, and according to this picture, this marking tells us it's congruent to angle 4, so if those are congruent, then the justification that we can say is that the lines are parallel because the angle relationship. So since angle 3 is congruent to angle 4, we know P is parallel to Q. So again, this is not our explanation. This is just a description of what's happening in the picture. And the last relationship we're going to talk about with congruency is if the alternate exterior angles are congruent, then lines P and Q are parallel. So in the previous video, we learned that parallel lines created the congruent angle relationships. Now we're looking at the converse, which is kind of confusing because at first glance, it looks like the exact same information. But it's really not. In this case now, we know that these alternate exterior angles are congruent. That's our beginning information. So since the alternate exterior angles of 5 and 6 are congruent, the conclusion now is that it's not about the angles. We already knew the angle relationship. But the conclusion is that P is parallel to Q. So this line is parallel to this line. So it's pretty much about what we were given as opposed to what we're finding. So in summary, these three relationships tell us if the angles are congruent, depending on what specific angle relationship it is, the conclusion we can make is that the lines are parallel. Then the last type of angle relationship we're going to consider is consecutive interior angles, or same side interior angles. So if consecutive interior angles are supplementary, then the lines P and Q will be parallel. So remember, this particular angle relationship is a little bit different from the other three. So now we have our pair of lines being intersected by a transversal. In our previous video, we knew those lines were parallel. We do not know that. But what we do know is that this angle is 120 degrees and this angle is 60. Now those two angles happen to be consecutive interior angles and they add to be 180. So since the consecutive interior angles are supplementary, then we can show that this line P and this line Q are parallel. Now that is a good if-then statement that we could use as an explanation, whereas these others that I had written would not be because they're specific. If you notice, when we explain something, we typically like to leave it so that it applies to any situation. So we don't normally use specific angle names or line names and so forth. All right, example 1 says to determine if the lines are parallel. Find the value of x that makes m parallel to n. Explain. So at this point, we do not know m and n are parallel. In fact, there's only one particular situation for x that will result in these two lines being parallel. We need to find that. So first we need to consider what kind of angles these are. Well, 71 degrees and the 2x plus 3 degree angle are corresponding angles. And the relationship that we know about corresponding angles that will result in parallel lines is when those are congruent. So congruent means we're going to use an equal sign in our equation. So 71 is equal to 2x plus 3. Let's go ahead and solve this. We'll take away 3 to isolate the variable term, and we find that 68 is equal to 2x, and when we divide, x is 34. Now, what that means is when x is 34 degrees, this angle will also be 71 degrees, and when those two angles are congruent is when those lines are parallel. So now when we write our if-then statement to explain our work, we're going to say if, and then we need to think, well, did we know the lines were parallel, or is that what we're proving? Well, we are proving that. So the if part is not going to be if parallel lines. We don't know that yet. What we're using as our given is the angle relationship. So if corresponding, we shouldn't name the angle here. We're just going to name the type. So if corresponding angles are congruent, then the lines are parallel. So the lines that we're talking about in this case are lines M and N. Example 2 says to use a transitive property of parallel lines. Each utility pole is shown, let's get rid of that is, that's why it wasn't making sense. Each utility pole shown is parallel to the pole immediately to its right. Explain why the leftmost pole is parallel to the rightmost pole. So essentially what we have here is it's giving that T1 must be parallel to T2. And T2 is parallel to the one just to its right, so T3. T3 is parallel to T4 since it's just to the right. T4 is parallel to T5. T5 parallel to T6. So essentially what transitive property tells us is since T1 and T3 are both parallel to T2, then we can bring that together to say that T1 must be parallel to T3. So we can repeat that process. Now we know that T3 in both of these particular statements, T3 is parallel to both T1 and T4. So we just continue to chain that together. So what that means is T1 must be parallel to T4. If we repeat that again, now T4 is parallel to both T1 and T5. So together those statements make T1 parallel to T5. And finally, T5 is parallel to both T1 and T6. So ultimately, we can show T1 is parallel to T6. Now, I know that was a lot to consider, and we're just joining those statements together. But really, I just want you to realize that this is called the transitive property. So the transitive property is just like the transitive property of parallel lines, and it's used to show relationships when you have many parallel lines to consider. Okay, so that's a property you should be aware of, both in the setting of parallel relationships and then transitive property in algebraic relationships as well. All right, go ahead and try the You Try Nows. It's important to focus on the different angle relationships we learned today, and keep in mind your conclusion for all of our relationships is then the lines are parallel. Have a good day, and I'll see you soon.